show you Conan and how we use it to package C and C++ dependencies. But first, I'll introduce myself briefly. So I'm Théodore Rieux. I work at Tanker, based in Paris. And I use Conan a lot at work to package for Windows, every Mac OS, Linux, and Android and iOS. And I'm also a very proud one-time contributor, as you can see. That's a start. So, Tanker, we are doing an end-to-end encryption SDK. The first version is available in JavaScript. And we're currently actively developing the Android and iOS SDK. So when we decided to develop the native version, everyone in the team was really excited because most of us are backend developers. But at one point someone asked, well, what language should we use? And then after a few days of constructive and intelligent discussions, we agreed on 3 key points that the language had to have. So the first of all is write once, run everywhere. Because we don't want to write everything in Swift and then in Kotlin or Java. We wanted one code base. Then high performance, especially for mobile devices, and also great or at least good dependency management. And that's why we chose C++. Now I know what you're thinking. What the hell is this guy talking about? C++ and good dependency management don't go in the same slide. And it's true that usually it looks like this fellow, the usual C++ dependencies. I mean, who doesn't love to upgrade OpenSSL on Windows, for example, or Boost? But that was before Conan. So Conan is a C++ package manager. It works with other languages, but primarily designed around those. It's decentralized, so you can host your own server. That's what we do. It's open source, available on GitHub, and it's written in Python. In Python, compatible with 2 and 3, so you can run it everywhere. So I have 2 parts now. I have one, the basic package creation, upload, and retrieval. So package management aspect. And after that, I'll show you more how we use Conan as a cross-build tool for Android. So first, there's the Conan create method, which allows you to create packages. So you have a recipe that I'll show in a bit. You can, Conan create will read the recipe, run it, and it will store the package in your local cache. After that, there's the Conan upload method, which will find local packages you want to upload, and then upload it to the remote of your choice. So here's how a recipe looks like. It's plain Python. So we import this Conan file from the Conan's Python module. So the Conan file is the basic framework we will use. So I have a small library called arithmetic, which exposes an add function. And so I derive my arithmetic Conan class. So there's a few attributes, the name, the version, and then there's the settings. So the OS and Arch that you see here are the operating system and the architecture on which the package will run. Build type, debug or release, and then compiler. Now we need to retrieve sources, so I will fetch the source from my GitHub account and simply run git clone. And then I will use the CMake helper in the build method to configure, build, and install my project. I will only use CMake during this presentation. Conan provides a lot of helper. You can work with Meson, AutoTools, and a lot lots of others, English. And then there's we need to expose to our consumers some information. In this case, which library they need to link against. There's others. There's other attributes by default, like the include directory, which is named include by default, so you don't have to specify that. So then, to consume package, you need to use the Conan install method. So there's an error in the slides here. It's not run recipe. It's check requirements. So there's a Conan file.txt that I'll show in the next slide, where you declare your requirements. So Conan install will read that file, then try to fetch packages in, either in your local cache or in remotes. And then finally it will generate build information files. In this case, CMake, so it will generate a Conan build info.cmake file containing every include, library directory, targets, etc., etc., like a PKG config file. So in our Conan file.txt, we have simply this section requires, and we have to put references to our packages. In Conan, references are composed of the name of the package, its version, and then a username and a channel. So the username is usually the author of the recipe, in this case me, and the channel can be compared to a Git branch. So like in Conan, by default, the stable branch, the stable channel is the master branch. And then we need to tell Conan we want CMake files generated. Here you can put a lot of other things. So I said PKG config. You can use even Xcode files. Don't use that. You can use that. And then one final thing to change to our project. So this is cmakelist.txt that was written before the Conan integration. As you can see, we have our calculator project. We have a find package. Then add executable, and finally we link our executable to the package that we found. If you use find package with Conan, there's only 2 lines to include. You have to include the file that Conan generated previously, and then you need to call this Conan basic setup macro, and that's it. If you like me and you don't like writing package files, you can simply use the targets argument to the Conan basic setup macro, and it will then Conan will create a namespace named Conan PKG and add a target for each of your dependencies. So here I replaced the arithmetic by Conan PKG arithmetic. So time for a little demo. So I'm inside the arithmetic folder, and I will use Conan create to create the package. So Conan create, it needs 2 arguments, the path to the recipe and the username and channel. Clean the sources, and here we go. So in the so here you can see Conan is running the source method, so cloning in the GitHub. Now it's launching CMake to build the package, install, and done. And we can see with the Conan search method with arithmetic, one. And here we can see we have a package in our local cache with all those settings. So now I want to upload this package to my Bintray account. So I have one remote, so FOSDEM, and then I rewrite this with up. You can see I upload the recipe and then the package.gz, I don't know. So now I will try to use my package. I will on purpose remove it from my local cache to show you the fetching from the server. So I will remove, I will cool. Yes. So I have my Conan file.txt. In my CMake, there's only the 2 include lines like I showed you before. So let's create a build directory and then run Conan install and give it the path to the Conan file.txt. So it tried to run on the default, the official repository remotes, didn't find anything. And so it found in FOSDEM 2018, download the package, and here generated the CMake file. Now, all I need to do is CMake, run CMake, run Ninja, and you can use our calculator. Great. So Conan auto-detected my settings, but you can specify your own. Like here, I want, let's say I have GCC 7, and I want to use a really old version of GCC 6, and I use the -S options to specify the setting. So let's say we want to build for Clang 5 with the newest GCC ABI, debug build. It gets a bit tricky because, yeah, it's hard to type, it's long enough. So there's a solution. You can use profiles instead, and that's what Conan uses when you don't write any settings. It generates a default profile, so that's the one generated on my machine, Linux, x64, GCC 7, and quick PSA. By default, Conan will put the libstud C++, the old GCC ABI, as a default. You don't, if you want the newest, you have to use libstud C++ 11. That's not something you want to discover after building 30 packages, like me. So let's refactor our command line, and we'll use simply Clang version 5 with the newest ABI in debug mode. And now we'll simply rerun Conan create, now with the / profile option, and giving our profile. You can still use the -S option to specify setting to override the default ones, or the ones specified in your profile. So now I'll focus more on the cross-building tool aspect and not so much the package management, to show you how we can use Conan packages to cross-compile for Android quite simply. So we have a list of prerequisites for Android building, the NDK, of course. We will use standalone Android toolchain, and we need a new Conan profile. But first, I want to introduce build requirements. So if you have a package A, which in its recipe is declaring self.armvinfo.foo equals bar, and that you have a package B that declares a build requirement on the package A, during the creation of package B, it will export the environment variable inside the environment of your shell. So inside package B, you could do echo $foo, and you have bar. Same thing with self CPP info that we saw in the previous slide. If I declare self.cppinfo.sysroot equals the path to my Android sysroot, it will appear inside package B in the recipe as self.deps.cppinfo.sysroot. And why is that useful? Because the CMake helper will be able to automatically detect that and set the sysroot accordingly. So what we'll do, we'll build a standalone toolchain that we have a build requirement on the NDK, and then we will throw the NDK and only use this toolchain, and here arithmetic will have also a build requirement on the toolchain. So before that, before showing you the recipes, there's our Android profile. As you can see, the OS and Arch have been changed to Android, ARM v8. There's this OS API level that is specific to Android. And then we'll use Clang 5 with libc++. And there's two new settings that have been introduced in Conan 1.0 to ease the development of build requirement packages. Because I want the NDK to run on my build platform, not on an Android device. And that's why OS build helps to make the difference. Otherwise, you will get a C++ compiler that can run on your mobile phone. You don't want to use that. So here OSBuild equals Linux and OSBuild equals x64. So the NDK recipe, like before, same Conan file start. And then the settings, we only need OSBuild and OSBuild, because we will fetch the precompiled binary archive for Linux x64. Then this package method, I didn't use it in the previous slide because CMake installs already did the job, but here there's no CMake, and all we want to do is copy everything from the Android NDK uncompressed archive to our package folder. And then, to be able to build a standalone toolchain, we need to have access to this build/tools folder. That's why we put it in our self.envinfo.path. So, which means in the standalone toolchain recipe, this build tools folder will be in the path, and once this toolchain will be created, it will be removed. So, the toolchain recipe, there's a problem in the slide. Same thing, we need OSBuild, OSBuild, and then we declare our build requirement on the previous package that we built. In the build command, we only need this make standalone toolchain.sh, which is located in the NDK tools folder. So we simply run it. And then in the package info, we set our sysroot. So build requirements can be specified in two ways, either in the recipe, but it's okay for a few packages, but here I want to use my toolchain each time that I want to cross-compile, and I don't want to use it to add a build requirement in every recipe. So what I can do is add the build requires section in my profile and put it there. And now, each time that I will use this profile, I will use this build requirement. So it's time for our final demo. I already downloaded the NDK, so you won't have to watch a progress bar for 10 minutes. So let's simply build the toolchain and my Android profile. I'm cheating a bit because I only handle one toolchain, ARM64, and that's it for the sake of simplicity. And then I have my toolchain, so I can show you inside my local cache. Here I have everything already packaged for compilation. So let's go into our previous arithmetic folder. And you Conan create. So now we can see the Conan output. So here Conan tells us your course building from Linux x64 to Android ARM64. Same thing as before. And here there's a build requirement. So our toolchain has been correctly detected. Simply, we haven't changed the arithmetic recipe, which is great. And now CMake already finds everything, the API level, the ABI, etc., the compiler, everything gets built. So I can rerun Conan search. Sorry, up. And now I have two packages. First one for my own machine, and here for Arch and Android API 21. And that's it. So I added a few links, so our website, our documentation, our GitHub, and the Conan website, Conan GitHub. There's also a Slack channel on the CPP link Slack. You can join the hashtag Conan, and I guess I'll take some questions from now.
Yes. Does it work on the Windows?
Does it work on the Windows? Yes, yes.
Is it possible to directly build deb or RPM packages from Conan?
I know, so the question is this possible to build deb or RPM packages directly from Conan? I don't know. I've only packaged C++ dependencies from, I have no knowledge in distribution package management, sorry, a bit of an intruder, but it might be possible, I don't know, I should check. Yes?
How many packages are there kind of pre-packaged available already, or how much did you need to do yourself?
Okay, so the question is how many packages are already available, pre-packaged, and how many I had to build myself. So I started to use Conan in the 0.20 version, so the focus was more on the code source and debugging, stabilization, etc. So there's more and more package on the Conan sender and the bean crafters repository. For Boost, there's a recipe that for Android, iOS, etc. you can use, but I had to do lots myself. Yeah. Yes.
Can you make a private repository or is it a public repository, the standard?
So is this, can you make a private repository? We own our own Conan server on our server at work, and yeah, you can, it's decentralized, so you can do whatever you want. You can host your own packages. That's what we do.
Is Conan also used for multi-language when there are also bindings involved? For example, if you have not only a C library but also with Rig.
Okay, so the question is, does Conan only work on C and C++ binaries? You can package other languages, but the helpers that are available, so the self.cpp info, the CMake helper, etc., are more focused on C and C++. But you can do that. I packaged GDK, and I think it works also for Go. It doesn't really care about that, but maybe you have to use a different class than the Conan file. Let's say the Conan file framework is more designed around C and C++, but yeah, you could make your own for another language. Yeah.
Is this popular? Is there a dynamic behind this technology?
So, yeah.
Is there a competitor in this area?
Is there competitors in this field? Is this dynamic? So there was previously an attempt for a C++ package manager. I think it was named B code, and it's dead. So, but on their repository, the guys behind Conan are very reactive. They're backed by JFrog, and yeah, they work full time on this. They're very welcoming. You can post any issues, and they will answer in the day. So.
So how do I bootstrap? So it's decentralized, and how do I know if there's already some channel out there which packages what I need? Is there some?
So how do I know if there's already packages for me on other remotes? So I use the Conan search method to search inside my own package in my own local cache. You could use it to look for remotes. By default, you only have 2 or 3 remotes installed. But yeah, since I've built everything almost myself, I had no use for Conan search, but I think it works great. You should try that. Yes?
I have a question. I think it's a bit the same, but is there like a list of remotes or central repository you can search?
Yes. So by default, sorry. The question is there a list of remotes that you can look for? By default, there's the Conan Center, really the stable master branch, the Conan Transit, And there's another organization, Beancrafters, that are making. They succeeded in making a modular boost installation. So I didn't think it was possible. So yeah, you can. They're doing a lot of packages. You can look for that.
Okay.
Yes.
Is there any API for licensing, like filtering by license?
So is there any API for licensing? I haven't shown in the demo, but in the attributes you can use license, and I think it can be, yeah, a search in. I need to check, but it will surprise me if it didn't work. Yes.
How does Conan do relocation of the binaries?
Sorry.
Does Conan relocate the binaries that it downloads?
So does Conan relocate the binaries it downloads? No, there's no. I don't think so. There's no. They don't touch the binaries once it's. So what do you mean exactly?
How do the dependencies know where to find each other? Is that your responsibility? As well?
Okay. So how does the packages find their own requirements?
Yeah.
Well, you declare them. I haven't used that, but if let's say I package zlib, and I want to depend on zlib on another package, so I've shown the build requires attributes, and there's also the requires attributes. So you just put yes.
Once it's linked.
Wait.
Right?
Yes.
Once it's linked, do you put RPaths or anything? Rely on LDS?
For building for third library, yeah, about RPath. So I mainly use static libraries at work, but for shell library you can I get the by default there's no RPath for on macOS. They're all stripped, so you just have the name of the library, and then it's your work to have some fun with install name tool, for example.
So on that note, how do you deal with, suppose that you're on a system that has an older libstandard C++ and you build something with the newer libstandard C++.
Mm-hmm.
Do you make the binary know where the new tool chain is, or do you is that your responsibility too, now that you built this?
Is that your responsibility to tell a binary where the C++ standard library is on a non-standard platform? So by default there's no RPath, but you can let them. But I think I had to say in the toolchain, for example, for Android, we want to build a tooling with the static lib C++. So we had to, in the toolchain, add link flags for every package built with that library, and then it worked. But for shared, I didn't use that, so it's quite a tricky question. Maybe we can see after the talk if you want. Yes?
To avoid to mess up with like system libraries or the one like you described with your package manager, like package manager on Unix or Spack, use a compiler or wrapper. Do you do the same or not?
In the you mean in the Android toolchain?
No, I mean when you compile software, let's say that I have Boost installed locally on my system. I install Boost with Conan. I have a lot of CMake. If they are badly done, they are going to use a local one, and I don't want that. So like you have some package that needs a Spack,
so how do you deal when you have a library installed on your system and the same library installed with Conan? So if you use in your CMake file the include that I've shown, it simply takes precedence over the system package. I don't remember exactly the CMake term, but it's the find module, and
expect the user to do it in CMake.
Yes, the CMake. If you just use find package or for example find package, which would usually find the system library, then if you use find package and include the Conan line, it would find the Conan libraries.
That's about all the time we've got.
Yeah.
We can do
Yeah.
switch over. Thank you very much.